Let's understand our new topic, which is fundamental theorem of arithmetic. In previous class we discussed the last brief review. The fundamental theorem of arithmetic says that any composite number can be expressed in the factor of prime numbers, and we say that simple way all like all the numbers is factor of prime numbers. We see that like a 20, we can say that using these clearly we convert in the factor of prime numbers. Okay, now the remaining HWs we solve and then move over next question. So our first question is 33. Okay, so first question is question number 1, which is 33. So for 33 we first our building blocks 33 starting from 2. No, for 3, so 1 1 and then 1 1. So the 33 can be written as 3 times of 1 1. Second question is 46. Second is our 46. So 46 written as 2 starting from 2 and 23 and again 23, so it become 2 times 23. And similarly for 981 it become 981. so for 2 no 9. Okay, then for 3 3 3s are 9, 3 2s are 6, 3 7, and again can 3 5 7 12 3. That's why I explain you the concept of divisibility rule of 2 and 3, because in here we can directly use the number 3. And similarly 3 1s are 3, 3 9s 3 0 1 9, and again now this is not divisible by 3. So now for 5 not 5, and now 109, so it become 3 into 3 into 109. So similarly you can solve all these questions. And for question 2, it is for divisibility rule. I solve only 1 or 2 question, then move over next topic. 24, the last part is 4, which is that's why we can say that divisible by 2. Similarly for 1 2 3 8 9 0, the last part is divisible by 2. And for 3 we can check like 10 10 20 20 and 23, not divisible by 3. It is divisible by 2 and 3. Okay, similarly the 4 5 5 4 9, it is not divisible by 2, because last unit digit is not 0 1 0 2 4 6 8. For 10 5 5 10 18 27, yes, it is divisible by 3. Similarly for 7 4 9 4 2 1, yeah, 7 4 9 2 1, yes. Okay, now sorry, 7 9 4 2 1. Okay, check for 2 unit digit not 0 2 1, since unit digit not is 0 2 4 6, so not divisible by 2. And for 3 9 10, and we can say that 10 21, yes, 21, which is divisible by 3, so it's divisible by 3. So I solve question this and this. The remaining part is again for your homework, and I think you solve the question number 3, that old question, and answer give me in the comment section which was and drop your also question. Okay, now we have some questions of exercise 1.1. now it's time for exercise 1.1. okay, exercise 1.1. First question is 140. Second question is 156, and third question is, you can see, 3825, and the fourth question is 5005, and the fifth one is 7429. First, the question 1, similar concept. The 140, write in the block section like 140, starting from the lowest to, then we move from the step by step in the upper, like when you moving the stair from lower to upper side. So 2 7 ja and 2 0, 235, then now to last digit not 3, then 3 not, then 5, yeah, for last digit is 5, so this can be 5, 7 and 7 and 1. Okay, so in previous class I explained the divisibility rule of 2 and 3. At last I explained for divisibility rule 4 and 5. Okay, so this become 140. I say 2 to the power 2, 5 to the power 1 and 7 to the power 1. Okay, and similarly for 156, second is 156. This is for yours HW because it's similar to this, and I use this 3825. now it is 3825, so write in the way 325. Similarly for 5 2, not divisible. For, let's check for 3, 8 to 10, 10 and 18, yes, it is divisible by 3. Okay, because 3 plus 8 plus 2 plus of 5, 8 10 18, overall 18. Okay, oops, sorry. Okay, so 3 1s are 3, 3 2s are 6, remaining 2, 3 7 3 5. Okay, and similarly for this 7 3 and 15, yes, again divisible by 3, so 4, because 7 plus 3 10 plus 5 15. Okay, now 3 4s are 12, 3 2s are 6 and 3 5s are 10 15. Similarly now again, can it divisible by 3? 4 plus 2 6 plus 5, not. And for 4, no. For 6, for 5, yeah, the last digit is 0 and 5, so it is divisible by 5. So 5 8s and 5 5s, 85, and again for 5 it is 17, and again for 17 it is 1. So by the help of divisibility rule it is quite easy. Okay, so the overall fundamental theorem of arithmetic, it is 3 into 3 into 5 into 5 into 17. Okay, similarly this is for your HW, and now going for the 7429. Okay, wait a minute, I'm using for this. Okay, yes, the question fifth, it is 7429. Okay, I'm using 7429. yeah, similarly for 2, the last digit is not divisible by the number 0 to 48. So okay, now for 3, 3, let's check 9 and 30. Okay, basically 9 plus 4 is 13, 13 plus 7 20, 22, not divisible by 2. And then now for 3, not 5, let's check for 5, no. For 7, let's check 7, 9 to remaining 18, so 742 minus of 18, it is become 12 minus of 8 4 3 2, and 6 again 62 minus of 8, it is 54, not divisible by 7. Then for 9, no, because the all 9 are not the prime number. 11, for the 11 it is the sum and the odd. Okay, so sum is 16 minus odd 1 1 2 1 2 3 4 1 2 3 4, So 13 minus 9, 4, not divisible by 11. Now for 13, is this divisible by 13? Using the divisibility rule of 13, using the divisibility rule of 13, 1 2 3 4, yeah, not divisible by, because it become 5 3 1. Now for 17, okay, so let's check for 17. So 17 4s are 64, and remaining 17 4s are 64, remaining 10 1, 17 6 are 102, and sorry, my mistake. So 17 4s are 68, remaining 6, 2, 17 3s are 51, and 119, like 17 7s are, okay. Similarly it is for now 19, yeah. Now for 19 it is 23. I am using, because I solved this question, so that's why I use it. So it become, the answer is 17 19 and 23, okay. So it is the all questions from it. Now it's time for the next one. The example number yeah, oops, the limit is exit. Now I solve the example question, exercise 1.1, question number 1, okay. I gave you HW. In the next class we will discuss the remaining part of this, and then we move for LCM and SCF, the factors, and we move some interesting questions, okay. So example are, do the exercise 1.1, question 1 again, and the remaining of question, the HW of previous, and the third one is do it yourself, okay, self question, okay. And the part where I discuss the divisibility rule of 4 and 5, let's summarize, and in next class we'll discuss in the detailed way. So for 4, the last 2 digit is divisible by 4, like 180, no, like 164. The whole number is divisible by 4 because the last digit is divisible by 4. Similarly for 5, if unit digit is 0 or 5, then the overall number is divisible by 5, okay. Example, 105 divisible by 5, 100 divisible by 5, 100005 divisible by 5. Similarly for extra one. So these are the divisibility rule of 4 and 5. In next class I'll definitely explain the detail, okay. I hope you understand this concept of fundamental theorem of arithmetic. If you have any doubt, please put on the comment section, and my humble request to all of you, please do the question number 3. I hope you understand. Bye bye.